Hello dear students, in this video we are going to study the second law of motion. Second law of motion. You all must be knowing that the laws of motion were given by Sir Isaac Newton. So before going to proceeding to second law of motion, I would like to explain you what is linear momentum. So first let us understand linear momentum. Linear momentum is basically the product of mass and velocity. So it's what is the product of mass and velocity. So product of mass and velocity is linear momentum. And this linear momentum is generally represented by letter P and mass by small letter m and velocity by v. So it's P is equal to m into v. Right. Now let's move on to the unit of linear momentum. So as you can see, the unit of mass is kg and the unit of velocity, the SI unit of velocity is meter per second. So the unit of momentum, that is the linear momentum, is kg meter per second. It can also be written as kg meter per second. Is it clear? So the unit of linear momentum is kg meter per second and it's the product of mass and velocity. So from here we can conclude from the formula that linear momentum is directly proportional to mass as well as linear momentum is directly proportional to velocity. If you are going to increase the velocity of the body, then also the linear momentum is going to get increased, and if you are going to increase the mass of the body, then also the linear momentum of the body is going to get increased. And also this linear momentum is a vector quantity. Linear momentum is a vector quantity. Is it clear? So what is linear momentum? Linear momentum is the product of mass and velocity, that is m into v. The unit of linear momentum is kg meter per second. It's a vector quantity, and here from the formula we can see that from the definition itself we can see that the linear momentum is directly proportional to mass and linear momentum is directly proportional to velocity. Now let's understand what the second law of Newton states. Second law of Newton states that the rate of change of linear momentum is directly proportional to the force applied, and the change takes place in the direction of force. Now, what does this second law state? That is the rate of change of linear momentum is directly proportional to the force applied, and this change takes place in the direction of force. So the rate of change of linear momentum is not change of linear momentum, it's the rate of change of linear momentum is directly proportional to the force applied. So more is the force applied, the change in the linear momentum will be quicker, or you can say the less, it will take lesser time to change the linear momentum, because it says the rate of change. The change, at what rate that change is coming in linear momentum, is directly proportional to the force applied. Now from the second law of Newton, that is from the statement of the second law of Newton, we can conclude that suppose there is a body of mass m, which is initially moving with initial velocity u, is being applied by some force F, say F. It was initially moving with velocity u, and its mass was m, and the force F is applied on the body, and after some time, say t time, after t seconds, the velocity of the body becomes v and the mass remains same, right? Here this velocity of the moving body is much smaller than the velocity of the moving body is much smaller than the velocity of light. So suppose there is a force F is applied on a body of which was initially moving with initial velocity u and having mass m is being applied by force F for t second, and and the velocity of the body becomes v after t time, right? T seconds, mass remains constant. So what will be the change of momentum? So the momentum, initially the momentum was m into u, and finally the momentum will be m into v, because this is the final momentum, that is mass into final velocity, and initial momentum will be mass into initial velocity. Then change of linear momentum will be equal to mv minus mu, that is the change of momentum. This will be the change of linear momentum. Then what will be the rate of change of momentum? Now the rate of change of linear momentum will be equal to mv minus mu upon t. So this is the rate of change of linear momentum. And from the statement, that is the second law of motion, we can conclude that the rate of change of momentum is directly proportional to what? The force applied. So this rate of change of linear momentum will be directly proportional to the force applied. Is it clear? So this the rate of change of linear momentum will be directly proportional to the force applied, that is mv minus mu upon t. Is it clear? Now when you're going to remove this proportionality sign, there will be equal sign with a constant k, that is mv minus mu upon t. Is it clear? Now f is equal to k times, we can take common, take m as common, and this will be v minus u upon t. Now v minus u upon t can be replaced by acceleration, because v minus u upon t is acceleration. So f is equal to k times ma. Now from experiment, the value of k is equal to 1. Therefore f is equal to m into a. So this is the formula for finding out the value of force. Force is equal to mass into acceleration, and this has been derived from the second law of motion. So this formula is going to represent the second law of motion. Now F is equal to m into a. Is it clear? So force is equal to mass into acceleration, and from where we have derived this formula? That is from the second law of motion. Is it clear till here? Now let's understand, this is force is equal to m into a. Now let's understand what is the unit of force. So from here only you can derive the unit of force, that is the unit of mass multiplied by the unit of acceleration, that is meter per second square. So the unit of force becomes kg meter per second square, which can also be written as kg meter per second square. Now this kg meter per second square is also called as Newton, and this Newton is represented by capital letter N. This is the SI unit, and this is the MKS unit. Is it clear? So force is equal to mass into acceleration, and the unit of force is kg meter per second square, which is also known as Newton, right? That is the SI unit, this one is the MKS unit. And force is a vector quantity. All of you must be knowing it already, that force is a vector quantity. It contains direction. Linear momentum was also the vector quantity. Okay dear students, so we will keep the lecture till here today, and in our next lecture I'm going to discuss more about the second law of Newton and more about force. So till then, bye. Stay home, stay safe, and take good care of your health. Bye bye, dear students.